Looking at our starter, if we substitute the x coordinates from the table into x squared plus y squared equals 25, remember our positive and negative square roots, we get these y values. Plotting these y values and joining up with a smooth curve, we see that x squared plus y squared equals 25 actually gives us a circle, centre 0, 0 and radius 5. We just have a look at this triangle. So I've drawn a right angle triangle between the centre of the circle and any point on its circumference. I happen to have picked 3, 4. If we look at this, horizontal distance will be 3, the vertical distance will be 4, so using Pythagoras that gives me a radius of 5. Looking in more general terms then, if I have a general any point on the circle of centre 0, 0 and I call that general point xy, drawing my right angle triangle, my horizontal distance will be x and my vertical distance will be the y coordinate, and using Pythagoras there we see that we get our equation of a circle is actually x squared plus y squared equals r squared, where r is the radius. So what would the graph of x squared plus y squared equal 100 look like? Have a think or draw a quick sketch. So you should have a circle centre the origin, radius 10. So in this lesson we're going to look at the equation of a circle and we're going to be looking at it specifically centred on the origin, which is GCSE work. We're going to look at if we can work out if a point lies inside, outside or on a circle, and we're going to solve simultaneous equations involving circles graphically and algebraically. So for our notes then, equation of a circle, centre the origin. The form of the equation will always be x squared plus y squared equals r squared, where r is the radius. So having a look at these two examples down here, if I've got x squared plus y squared equals 16, I know my centre will be at 0, 0 and my radius will be the square root of 16, which is 4. X squared plus y squared equals 144. Centre again 0, 0, radius, square root of 144, which is 12. Turning the question round, if I want a circle centre the origin, radius 8, I know I've got x squared plus y squared equals the radius squared, so 8 squared. So my equation of my circle is x squared plus y squared is equal to 64. Right, pause the video then and just have a go at writing the equations of these different colour circles into your book. So for blue you should have x squared plus y squared equals 81. Red, x squared plus y squared equals 49. Purple, x squared plus y squared is 16. And green, x squared plus y squared equals 1. Right, let's look at some example questions and write them down in our notes. So, show that the point minus 4, 7 lies on the circle with centre 0, 0, radius 65. So in order to show this point lies on the circle, the first thing I've got to do is write down its equation. Well, if it's centre 0, 0 and radius root 65, I know the equation is going to be x squared plus y squared equals 65. And if I want to show that minus 4, 7 lies on the circle, I've got to show that minus 4, 7 satisfies the equation. So let's square the x coordinate and add it to the y coordinate squared. That will give me 16 plus 49, and that does equal 65. So therefore we can say that's correct. Minus 4, 7 lies on the circumference. How about this one? Does the point 1 minus 3 lie inside, outside or on the circumference of the circle x squared plus y squared equals 16? So this time we've been given the equation, so let's test our coordinates. X squared is 1 squared plus y squared, so I want minus 3 squared, so that gives me 1 plus 9, which equals 10. So I can now say, well, 10 is less than 16. So obviously this point is going to be inside the radius, so it's going to be, we can say 1 minus 3 lies inside the circle, lies inside. So we can just test these coordinates by substituting into the equation of the circle. So this example, it gives me a circle centre 0, 0, but instead of giving me a radius, it gives me a point on the circumference of the circle, root 6, 4. So I want the equation of the circle. I know because it's centre 0, 0, the equation of the circle will be in the form x squared plus y squared equals r squared. So if I substitute in these coordinates, so I've got root 6 squared plus minus 4 squared, I know that that will give me my r squared. So I'm going to get 6 plus 16 equals r squared. So 22 equals r squared, so I know that r is equal to root 22. Actually, I could have stopped at r squared because right down the equation of the circle, I know that x squared plus y squared is equal to 22. One last example then, let's look at how we can solve simultaneous equations involving equation of a circle. You have actually looked at these before algebraically without knowing that the x squared plus y squared equals to 9 was an equation of the circle. But let's look at doing this graphically. So it says construct the circle. So that word construct is quite important because that means that you need to get out your compasses to draw your circle. So it's x squared plus y squared equals 9. So we know we've got centre 0, 0 and radius 3. So there's our circle. By drawing an appropriate line on the grid, solve the equations. So I've got my x squared plus y squared equals 9. In order to solve simultaneously with the line x plus y equals 1, that means that I need to draw the line x plus y equals 1 and see where the lines intersect. So to draw the line x plus y equals 1, remember with these type of lines it's often easier to say, well, when x equals 0, y will equal 1, and when y equals 0, x will equal 1, so I know it's going to go through these 2 points here. And if I draw that line in, I get the line x plus y equals 1, and then to find the solutions to the simultaneous equations, I need to find the coordinates of where the two graphs intersect. So my solutions will be, looking at this coordinate here, I will have x equals 2.6 and the corresponding y coordinate is minus 1.6, and for this point of intersection up here I've got x equals minus 1.6 and y equals 2.6. So those are the solutions to my simultaneous equations graphically. Of course, you could always solve these simultaneous equations algebraically, and you should be able to remember how to do that. So pause the video and have a go, and then you can come back and check your solution. So actually here it will be easier if we divide everything through by 2. And then I'm going to use the quadratic formula. And as we would expect, when I get x is 2.6, if I substitute that back in, I get y is minus 1.6. And then also my second solution, I get x is minus 1.6, substitute that back in, I get y equals 2.6. Okay, these are the questions I'd like you to have a go at. So you want your pink Edexcel higher textbook, page 385, have a go at these questions, and then you'll find the equation of a circle worksheet in files on Teams. Actually, it's got a 1 underscore, and you can have a go at those questions there.